this will be a small fun exercise creating rain splashes with VOPs. Now generally this kind of effect is usually done with the shallow water solver or even the old ripple solver, but the idea is to create this kind of effect with VOPs, which gives you more control over how the ripples look and behave, but also this will have a lot more carryover to other setups as well. We have to remember that knowing how to control attributes is really the cornerstone of anything we do in Houdini. And this workflow that we're going to use is really the same workflow that is used for super complex effects. If you want to download the HIP file, check out the link in the description. And before we get started, Particle Effects in Houdini and Nuke is open for enrollment. Over 40 hours of structured training covering a variety of techniques to create particle trails, explosions, tornadoes, but even other effects like destruction, revealing effects, and much more. So let's get started and we'll drop down a geometry container. Let's rename this one to Effects Rain and step inside. We can start with a simple grid and we can keep this at a 10 by 10 size. Size isn't really important in this case since it's not an actual simulation. So we can really scale this to whatever size we want, but we will increase the rows and columns. We need some subdivision, so let's do 100 by 100. And I will drop down a subdivide, which we can just use to control really the resolution overall of this grid. So we can do some tests with a lower quality if we keep the depth here to 0, and we can just increase the quality and preview this effect really at different kinds of resolutions. For now, let's just leave the depth at 1 and let's drop down an attribute VOP and start working on the setup. And let's press Shift W to remove the wireframe display. We can rename this one to, let's do splashes, and we'll step inside and let's start by just creating one splash or ripple right in the center of our scene. And what we are going to base this entire effect on is going to be the sine wave or the sine function. So if we remember from Intro to VOPs, and really if you are brand new to Houdini, I will recommend taking the free Intro to VOPs video on the website, so you'll have a better idea on the steps we are going to take in this tutorial. But what the sine wave will do, what the sine function does, is if we have an increasing value, in this case we can just create a gradient. So for example, if I grab the position and I do a vector to float, we can use here either the x or z direction. So if I plug the first value, which will be the x coordinate of our world position, if I plug this inside the CD, we will have this increasing value that goes from -5 to a value of 5. And if we run a sine wave through this value, if we just plug here a sine, we can see that this will now create for us a repeating pattern. So what we can do, for example, if I just multiply the value before the sine wave, so I do a multiply constant here, I can control the frequency of this repetition if I just increase the multiplier here. And the sine wave will output values for us from -1 to a value of 1. So all these dark areas over here really go below 0, so they go in the negative direction as well. And we can preview this better maybe if we use a displacement instead. So from here, from our sine, let's use a displace along normal and let's use this as our scale, and I will just plug this result in the position. And now if I increase the displacement amount, we can see exactly what's happening here. So we can see that the values fall below 0. And we can also offset this pattern. We can make it go in the direction that it's facing, sort of, if we just increase our value here. So after we do our multiply constant, if I do an add constant and I increase the value, we can see how we can kind of create this moving value. Now, this add and the multiply constant and our sine function is all packed up inside a node which is called trigonometric functions. And here we already have our frequency, which is the multiplier, and we have our offset, which is this add. And then we have, for the function, we can choose from really more options here, but the most common ones is going to be sine and cosine. There's not much difference between these, except the cosine will start from -1 and it will go to 1, whereas the sine will just start from 1 and go to -1. So it's really just a matter of where they start. So we'll just use the sine function here, and we can plug this back inside our radius, and I can just remove our 3 nodes over here and just use this one instead. And if I reconnect our values here, we can see, let's connect this here as well, and now I have the option to control the frequency and also the offset. So the same thing we had earlier, but this is just a little bit cleaner. So this is what we want to use, and let's go ahead and maybe disconnect and get rid of our displacement. Let's just plug this inside the CD, and instead of using a linear gradient like this, we can use a radial gradient. And in order to create this gradient, we can use a distance function. So from our position, we can measure a distance from all of our points and let's just keep this towards the center for now. And if I plug this inside the radius and replace our vector to float, we get this. So if we were to just preview the distance, we can press X to drop down a visualized node, and we can see that this is the gradient that we have. So our increasing values will spread out from the center towards each of our points on our geometry, and then when we run a sine function on this gradient, we will just get our repeating patterns like so. And now, for example, I can let's go ahead and let's start by using the time as our offset, and we should be able to play now our animation, and we can see that the waves are moving. And we can just straight away start to create some parameters for us. So let's do a multiply over our time. We'll promote the second input, and this will be our speed. So if I go up, we can start maybe, let's do a value of 5, and let's see how this looks. All right, we'll probably come back to adjust all of these values later. And we'll also need one for our frequency. So let's also promote the frequency here, and we can just keep the label as frequency. So now we can increase the amount of waves we get. So if we play this, this is the result. And let's also do our displacement, but in order to keep things a little bit cleaner, let's use another attribute VOP instead for our displacement, and let's rename this one to displace, and we'll use our color value that we have from our first attribute VOP as our displacement factor. So let's grab our CD, let's do a vector to float because this is a vector and we want to use float values, and we'll plug this inside a displace along normal. We can keep this as the amount setting, and we'll plug the result in our position, so we have this result, and we can promote our scale now. So let's promote the scale parameter, we'll go up, and now we can control our displacement. So let's press play and see what we get. Pretty cool for now at least. So one thing that we can do is we can avoid having our waves go below 0, and we can just keep them going from 0 to 1, so we can reverse whatever has a negative value, and we can just turn it into a positive value. If we go back in our attribute VOP, after our trig node over here, we can run an absolute function, and this absolute will remove the negative from our numbers and will turn them positive. So whatever was going from 0 to -1 is going to go to 0 to +1, and our 0 to 1 values, which were previously there, are just kept the same. So we end up with this result. And if we wanted to shape our waves a little bit more, we can also do let's use a ramp parameter, and let's with these ramp parameters you always have to give them a special label and a name. So let's use the name here ramp wave, and let's also copy and paste this in the label, and let's use spline ramp, and let's go up and reset the ramp with control and middle mouse click, and now we can either squeeze the shape of this wave or we can make it a little bit thicker, but let's go ahead and squeeze this, and let's also set this to a B-spline. So we also have the option to shape things up a little bit. Now obviously we don't want this to spread throughout our entire grid, so let's go ahead and just taper down our waves as they go further away from the center. So if we go back inside, we already, let's actually go to our splashes VOP over here. If we go back inside, we already have this ramp that we need in order to scale down our waves with our distance node. So from here, we can do a fit range, and we can use this as a multiplier, as sort of like an overall multiplier for our waves. So if we do a multiply after the ramp, and let's maybe reorganize these nodes a little bit, and I'll press Shift S, so we have this curved wiring. If we plug this inside our multiply, I can preview again the result of this fit range with X. So now what we want to do is reverse the destination mean and max. We can do here 1 for mean and 0 for max. So now we can see that we are just having this wave right in the center, and I can increase the spread with our source max value over here. But what we want to do to better control this as well is maybe just use another ramp as well. So we can do another ramp parameter. Let's place this over here, and let's rename this one to ramp radius, and let's also paste this inside the label. Let's use spline ramp, and let's plug this over here, and we can also visualize this. We'll also plug this inside our multiply, and let's we can probably get rid of this visualizer for now and just use this in our multiply. So if I go up and reset this radius ramp, we have this result. And let's also get rid of the color after our displace. We can just use another color node. So we just say this in a white color. So if I play the simulation, this is what we get. And now we have this control over our radius. So for example, I can taper this out as well. So it's just not, it's not just a simple linear fading. And maybe I can increase the scaling for now just so we can preview this. If I go back to our splashes, I can just use another exponential ramp like so in order to have this stronger pushing right here in the center, and then a smooth tapering out throughout the rest of our area of effect, so to say. So if I play the simulation, or rather just animation, because this is not a simulation, let's maybe reduce the scale back down. We have this effect, so definitely we are getting close. Now, one final thing that we can add over here before we move to our second step is really we can just introduce some noise on the overall amplitude of this effect. So if we go back to our attribute VOP, let's go ahead and just duplicate this VOP global node by holding Alt, and from our position we'll do a turbulent noise. Let's set this to a simplex noise, and let's use a fit range as well. And if I plug this inside the CD for now, we can preview the result of this. So maybe we can reduce the roughness, and maybe we can increase the frequency. So let's reduce the roughness even further, and let's maybe decrease the source mean here and maybe the source max as well. So this is what we want to use to break up our perfect waves, and we can just introduce this fit result in our multiply as well. Let's maybe plug this back into our CD, and now we can see we have this result. Now probably this is a little bit too strong. We can increase the destination mean here, so we make sure that this is not super destructive, and we can play around with the source mean and max. We can go back to our noise. Maybe we can smooth this out even further. We can use a roughness of 0, and this is the result that we get. We can also animate this noise. If we animate our second offset value over here, we can also introduce some animation, and we can just use the time inside a float to vector, and we want to use this as the second value, and we can just plug this inside our offset. So now we'll have this automated animation. All right, and this is the result. Probably I would say that this is still maybe too much. We can go to our fit range, and we can just increase the destination mean. Maybe we can reduce the frequency a bit, and we'll probably have to come back to these values either way, but this is the result that we have so far. So this is looking good, but obviously we will need to spawn multiple splashes throughout this entire grid, and we don't want this continuous animation for all of the splashes. So what we can do is create a particle simulation over this entire grid, and then bring all of those points with their attributes inside this geometry VOP and use all of the built-in attributes that particles have, like age, ID, p-scale, and so on, to combine those values with our current setup. So let's go up, and let's start from our regular grid. We can drop this inside a pop network. And if we go to our pop net, we already have some points here. Let's go to our pop source and disable the guide. Let's go to the birth tab, and let's reduce the birth rate first of all to maybe 500. And if we press play, this is what we have. And we can also decide how long we want each splash to last. And let's maybe try a value of 1 or maybe even lower, 0.7, and also introduce some live variance like 0.3 or something like this. And now we can preview, and we can kind of have a feeling on how long a splash can last. So maybe something like this is good. Let's start with this, and we can come back later to adjust. So if we go up, we can source this simulation inside our attribute VOP. Let's maybe rearrange the nodes, press Shift S. So we'll plug this as the second input in our splashes. Let's preview our color node. And if we go inside, first we will want to rewire the position so that it's generated not towards the center of our scene, but from the center of each particle point that we spawn. So we will need to look in our second input, which is our particle simulation, and we want to import that point's position, but we will need the point number in order to bring in this position attribute. So we will need an import point attribute. So with this, we can grab any attribute that we want. By default, it's going to be position, which is what we want for now, but we don't know the PT num value over here. So we can use a near point function to find from our own position. So we'll generate this from our own position. This will give us the point number which is closest to our own position from the input that we specify. In this case, it's going to be the second input, which is our particle geometry. So this will find the point number of the particle that's closest to our position, and this is the point number that we want to bring in whatever attributes that we need. So we'll bring in the position for now, and we'll just plug this inside our second input for this distance node, which previously was the center of our world. So if I plug this over here, we have something happening, but the problem is that we are scaling this down with our radius over here. So for example, if I were to disconnect this radius modification from here, so I'll just cut this wire for now, we can kind of see that something is happening with our points. And let's also disconnect our noise for now as well, so we can focus on what's happening. And for our import point attribute, we also want to look into our second input as well. So this file input here should point to our second op input node here. So now we are kind of getting the result that we want. We can preview what's happening over here from our distance. If we grab this and press X, we have this visualizer. We can maybe just go up, and let's ignore our displacement for now. Let's just look at our splashes, and we have this 0 to 1 gradient that's starting from the center of each of our particles. So this is what we want. And let's go back to our color. Let's go back inside and get rid of the visualize node. And we also have some animation. So if I go up and I can increase the frequency here, we can kind of start to see our splashes. So if I press play, we have this, and maybe we'll just decrease the amount of displacement that we get. So now we are kind of starting to see the result that we get. So let's go ahead and inside our attribute VOP, let's try to reconnect our radius and our noise. So if we reconnect our radius, this should work because it's based on the same distance from the center of our particles. So let's plug this back here, and it kind of works, but we have to go back up, and we can decrease this value here. We can taper out maybe our particles even more, but we will also probably want to control the radius for this. So if we go back inside our attribute VOP here with our fit range, our source max is 2.4, which is way too big now considering the position of our particles. But let's go ahead and promote this, and let's rename this to radius max or something like this. We'll go back up, and now if I reduce this radius max, we can kind of see that we can control where our tapering happens, and maybe we can increase the frequency even more, and we are starting to get more of the result that we are looking for. Let's maybe increase the scale, and this is the result that we get. So it's starting to look like actual splashes. We can maybe, let's try to increase the subdivisions for now to preview a smoother result and see if we still have a fairly decent speed in our viewport. I'm still running 24 FPS more or less, which is great. So this is where we are currently, and a few more things need to happen. The first thing that I would like to add to this setup is fade out our splashes based on the age of our particles. So for now, what happens is that whenever our grid, our setup detects a point, it's going to create this wave animation, but when our point gets removed from our particle system, it's just going to be cut off entirely. So if we preview some of these splashes, if we look at them, we can see that they start really out of nowhere. There's no sort of radius growth over time, which we'll have to fix as well, but they also get cut off instantly. So we can see if we just look at this splash over here, if I go frame by frame, it's just instantly cut off from one frame to the other. So let's bring in our age into the mix. So we'll go back inside, and using the same import point attribute node, we can duplicate this by holding Alt. Make sure that this is connected to our near point and our op input too. And instead of looking for our position, we'll grab our age. So let's set the signature here to float. We have to make sure that whatever attribute we are bringing, it has the correct signature. So in the case for age, it's going to be a float value, and this will just increase linearly from 0 to the maximum number, or rather the maximum life that we have. So we can remap those values as well. Let's go ahead and let's plug the result inside a feet range, and the source max should really be our life. So we can also make another duplicate of this, bring in our life, and let's use this as our source max. And now from our feet range, let's maybe make some room from this feet range. We can use a ramp, but really what we want to happen here is just decay our amplitude over time. So we'll set the destination mean to 1 and the destination max to 0. So we'll use this as another multiplier over here. Let's maybe bring this down below, rearrange things slightly. So we'll bring this as our third value for the multiply. And now we can already see this is probably working. So they have a smooth fading out over time, which is exactly what we want. And the other thing here will be to fade in our particles. So we want to modify our radius over here. We can see that this source max, if I were to expand this value, if I do a multiply constant for now over here, I can scale up our source max over time as well. So if I grab this multiplier, we can see that if I start from 0, they will be completely faded out. And as I increase this value, our waves are sort of expanding to their maximum radius. So we just want to scale this value with our age as well. So let's do another multiply here, not a multiply constant. So with our source max, we want the same kind of treatment that we have over here, only we want our values to go from 0 to 1. So let's go ahead and duplicate this one. Let's set this to 0 and 1, and let's plug this inside our multiply. So now each splash will start increasing its radius when a particle is spawned. And this is the result that we get, and we are getting really close to our final result that we need. Probably I would say that right in the beginning here, our initial splash is kind of large, so we can go back up and we can modify our ramp radius a little bit. Maybe we can add another control point over here, and we can grab our very first point and just start this from a lower position. So we have something like this. All right, so this is going back to the amount of control that I mentioned earlier that we can have with this kind of setup. So really this is kind of impossible to control perfectly inside an actual simulation. So if I want, I can control the frequency of our waves. I can just increase the speed overall, and everything is in real time. We are only needing really the particle simulation here, but we can control all of this, or most of the parameters that we need, in real time. So we can control how our waves kind of look. We can control the frequency again. Let's maybe try to increase this. And one thing with the frequency, one really cool thing that we can do here, if I set this back to maybe 25, we can also skew our, or rather the width of our waves, so there may be a little bit, so they maybe have a higher frequency right around the center of our particles, and then slowly they taper out as they expand. Let's maybe increase the overall radius. Let's increase this value here. Let's maybe push this over 1. So we have something like this, and after this color node, we should really use we should recompute our normals. Let's set the cusp angle here to 180. So what we can do if we go back inside is on our frequency over here, if we double click this handle to expand our property, we can also scale this based on the same distance. So if I just make some room over here, we have our initial distance towards our particles. Let's go ahead and use a fit range, and let's use a multiply on our frequency. Let's maybe drag these up, and I'll plug the same gradient inside this multiply. So now we'll have a higher frequency as we go further out from the center, but we want the reverse effect of this. So if I set the destination mean back to 1, we'll have the same result that we had earlier. But if I decrease the destination max, we can see that the outer waves here start to sort of get a little bit more thick. So I can also reduce our source max, so it's more focused around the center. And I can increase the destination mean above 1, so we have more frequency right in the center, and we have less frequency as our waves get further away from the center of our particles. So we end up with something like this. So this is also something that we can easily control now and art direct, which is really, really cool. So really, this is the main setup, and from here the sky is the limit, because we can also randomize certain attributes per individual particle. So we can also grab, let's maybe make some room here, we can also grab the ID of our particles. If we do another duplicate of our import point attribute, we can grab the ID, and this will be an integer value. So based on this ID, we can create a random value from 0 to 1. So for example, really the first thing that we can do is multiply, or rather affect the overall scale of our points, so the amplitude. Let's use a fit range, and let's use this as another overall multiplier for our setup. We can already see that some of these splashes will have a way lower intensity, so we can control this now with our destination mean. So now we can also control the radius of these splashes. So over here, before our ramp radius, where we have our multiply with our other setup based on our age, we can also do a duplicate of this random value based on our ID, and we can probably, let's see, if we plug this over here, we can see that some of these particles now have a bigger radius, so I can increase these values. We can do something like this. Let's maybe use 1.5 and 0.5 or something like this, and we can kind of see, we can start to see the possibilities with this effect. Maybe this is a little bit too much. Now we can notice in some places there's a hard cutoff over here. So when two particles are really close to each other, we have this kind of ugly cutoff, because the points that are closer to this particle will have different values than the points that are closer to this particle. So we end up with this kind of weird cutting off. Now for this effect specifically, we can kind of smooth this out a little bit. So if I go up and I increase the divisions here to maybe 3, and this will now kind of slow down our system. But from here, what we can do is maybe just run an attribute blur over our position, and we can increase the blurring iterations. So we can kind of try to smooth things out a little bit. Let's maybe compute the normal after this attribute blur, so we can see exactly what's happening. Or we can also play around with the normal itself, but really I just want to fade out the position a little bit. We can also use a weight attribute maybe, so we can just select the parts which we want to blend. Maybe we want to keep the center of our splashes more intact, but this is up to you. And for the most part, I would say that this holds up for the kind of effect that we are going for. But again, really it's just more of an exercise in how to manipulate attributes in Houdini. And we can also introduce back our noise over here. Let's plug this back. Let's bypass the attribute blur just for now, because this really tends to slow things down, and we can just preview the result that we have. And probably this looks better with less division, so something like this. I think we have a pretty cool result. Now we can also, let's maybe set this back to a value of 3, and we can also break up this hard cutoff between our points if we introduce some noise over the position from where the distance or attributes are generated. So if we go back inside right over here where we have our near point, if we drop down a turbulent noise, and I set this to a 3D noise, set this to simplex, and displace our position before we grab our near point. So I will drop down and add, and just add over our current position this turbulent noise. We can see that if I increase the amplitude, we can sort of break up this cutoff a little bit, especially if I increase the roughness and the frequency. We can kind of see the result that we get. Now this is maybe a little bit too much. It might not work that well in this case, but it's something that you can do maybe for a different setup. So this is what I wanted to show you. Hopefully this was useful and it gave you an idea on how some of these setups work in Houdini. And definitely let me know if you want me to do more small fun exercises like this. So there's really a lot of setups we can explore. Definitely let me know. But that's it for this tutorial, and hopefully we'll see each other again in the next video.